a Watkins Custom 15. Really nice little amp, very good condition. Custom 15 controlled power amplifier. Maybe their other amps weren't controlled, but this unusual appearance, don't know who they made it for, but probably for use in a jazz band or a big band or something. It's slightly Art Deco looking. Watkins Electric Music London, little treble clef down there. Pretty good condition. Now, if it's quite small, so looking at the back panel, this is very familiar from a load of their amps, from the Dominators, Westminster, Scouts, all sorts use this chassis. Now this one's nice and gold. I assume these were gold originally, they faded. Inside it's got the back on it, and a rare find. I've still got the foot pedal. They always go missing, and it's a matching gold, so that is a bonus. Anyway, a nice little solid. When was it made? I reckon about early from 1970 or just before. So take the back off and then we'll see what's inside. Both the back panel fixing pieces have fallen off. Wasn't enough glue, it's gone old. So I need to stick them on with some PVA wood glue. I'm hoping that the these other battens inside are not going to require re-gluing. Okay, one thing that's I've noticed on this Custom 15 is this aluminium front panel. It tends to vibrate at high volumes quite a lot. Normally the trouble with old Watkins is that their luggage handles, which is plastic, this is not one, normally vibrates like hell. Now on this one it's this aluminium front panel, but it might have been glued originally to the back panel, I don't know. Anyway, there's a bit of a gap underneath here. I think I can jam a bit of rubber strip up under there, and it might stop it rattling. Okay, the front piece of trim, this aluminium trim has fallen off. The glue has gone rock hard. Because this is aluminium, it's so bumpy, I shall use some shoe glue, which is quite thick, flexible and tough to stick it on with. And I'll clean up the front panel with some Pampers Natural Clean, which hopefully will get off these marks. Works very well indeed. Taken the back off, and I'm pleased to see that everything looks original, not been messed around with. These valves even look original. They're yellow label Mullard EZ81, 284s, 3 ECC 83s. This is the circuit board version of the Dominator, which works fine. We've seen plenty of variations of this. Mullard capacitors in the tremolo section is good, so it probably works fine. In fact, these Mullard capacitors very rarely fail. They should be fine. Plessy capacitors, I've tested these before and found that they've been fine. Paper labels shrink and fall off. We'll check this one, see if it's okay. And I have to check this big smoothing capacitor here, but there's no swelling on it or anything. And that should have a date code on it, which will give us a pretty accurate date for manufacture. Nice ELAC 10-inch speaker, very small Alnico magnet. Still got the label ELAC on the side. So is it 10-inch or 8-inch? Anyway, it's the small speaker. So I'll pop the chassis out and we'll have a look at the date code on the capacitor. Drop the chassis out so I can turn it over. It's a bit of a fiddle to get out. There's 2 bolts either side and a nut on these threaded parts here, both sides. And look at the gunge on that's accumulated on here. I don't know why it's so gungy. Anyway, here's the capacitor, and whether or not it's got a date on it, yes it has, look at that. June 1964, so this amp looks like it's a lot older than I thought it was. These capacitors wouldn't have been in stock for like ages. They get these capacitors in and use them straight away. They're expensive in those days, capacitors, just as expensive as the transformers. So here would be a high frequency stability capacitor and resistor on the output transformer. Quite a nice idea. It stabilizes it nicely at high frequencies, stops any instability. We don't really do that anymore, but it really does give a nice load to the EL84s at high frequency. So I just everything looks good on this side, so I'll just get some of the dust off. And the control panel is pretty filthy. What I use is some of these Pampers Natural Clean fragrance free. They're extremely good for getting off dirt and grime without leaving any stains or marks. So if I can take these pots off, then I can get this nice, and that should clean up very nicely. Nice row of yellow labelled mallards, which I shall test on the Avo Mark III. I'm sure they'll be fine. They don't look like they've had too much use. So I'll test them, and then I'll just check over the rest of the circuit. Checked all the components in the amp. The only one I've decided to change is this 15 microfarad 350 volt one that supplies the smoothing to all the preamp valves, including the tremolo, 3 ECC83s, and it's only measuring 13 microfarads and ESR 0.79. So I had to put in a modern 33 microfarad, which is a low ESCR, which makes sure that there's very little noise on the preamp section, so it'll be nice and stable. All the other capacitors, these low voltage ones, are good enough to leave in. So I'll keep that just in case anyone wants to put it back in, but it's the only component that's needed changing. A quick explanation of the circuit operation of the Watkins Custom. I've drawn out the complete circuit diagram here. Now 235 volts, and the very happy, ramped it up, checking all voltages are working okay, and I'll just show you a few of the voltages. I've written them on the circuit diagram. So our main selector comes in here. There's no bonded earth point on these old amps, but you can put one on. The circuit board in fact carries the earth all the way down to the chassis bond point, which is down there, which means if there is an earth fault, the current will run all the way down the circuit board from the mains transformer all the way down to there, to the chassis, which will probably burn out. So normally the earth green wire here would be bonded to the chassis. You can do that. Anyway, checking the circuit. It's 320 volts coming out of the rectifier. Up here, which obviously feeds the output transformer. Now on the output transformer you've got these snubber circuits which provide a nice load to the EL84s at high frequencies. Working out the frequency here, you're just using 1/2 pi RC, using the components they give you, the 0.022 and the 4.7K, 15 kilohertz. So that gives you the load on the transformer onto the output valves. Because if you look at the EL84 specification, it says here operating in push-pull. Now the anode to anode load should be 8 kiloohms. Well, at high frequencies that wouldn't be if you didn't have those snubbers in. But so using two 4K7s together, which is near enough to 8K. which gives you a perfect load at high frequencies, stop any oscillations. Looking at this as well, it says the cathode should be 270 ohms per valve, so they've used 270 ohms, which are in here, these ones. So just following the recommendation and measuring the voltage across them. Got 10.28, the 10.3 on one, and well, I haven't got a meter on the other one, but I did measure it and it's just about the same because I checked all these valves and they're Mullard's nice match pair, so, and they're doing 39 milliamps if you about 10.3 across 270 ohms. These are the 50 microfarads across each one to give you nice gain on the output stage. 100 ohms on the extra grids G2, running off this point here, which is through the 1K5, 299 volts. Then it's dropped to 249 volts, which feeds this one stage here, the ECC 83. It's very standard. It's got a 56k load because it's supplying both valves off the 56k, and also the cathode is common, 1.66 volts, 184 volts. And the mod, which I've shown here, where you can actually combine the two inputs very easily, just a simple wiring. So when you plug into one, you feed through both ECC halves of the ECC 83 together, which gives you a little fatter tone. It's worth doing. Now the volume and tone controls are a bit odd on these old Watkins. They you wouldn't really do it this way. They use the tone control like it's also a bit of a volume control, because when it's fully up it's passing all frequencies, when it's down cutting the high frequencies, but you're also adding in some resistance as well, so the volume goes up and down as well as you adjust the tone. Then standard volume 2 meg pots, and capacitor 10,000 picofarads on this one. It's one side of the phase splitter, and on the other side they got 22,000, or was it 2,200? 22,000 picofarads. I don't know why they didn't use the same capacitor. Well, actually, on the tremolo section, this has the on-off switch combined with it. There's only a 500k pot, where this one down is a 2 meg pot. But the tone control is still the same, 100 picofarad. Measured 770 picofarads and 750 picofarads, and I couldn't read the values on them, but so the phase splitter, this is one of the older designs where you use two resistors from the power from the supply to give you the voltage point the voltage to bias both sides. Because any hum on there is on both sides, it cancels out, so it does work. But on later designs they tap the voltage off with an extra resistor on the cathode. Anyway, 1 meg, they use phase splitter one side for one channel, one side to the other. All this is normal EL84s. The tremolo section, we've seen this on loads of Watkins, it's a standard design. The phase shift through these 0.01s and varying the speed on this 2.2 meg, 470k foot switch here, which switches it in and out. Doesn't go that slow. You can increase the size of one of these capacitors to 0.02, which will slow it down a bit. Depth, winding this up and down varies the gain of this ECC83 here. This voltage goes up and down a bit, and some values here goes 0.74 to 1.32 as you go up and down, and it varies. On the anode it goes 73, 119, and then this capacitor here stops the thumping in the speaker. It's very effective, a little bit of feedback. And again, the voltage goes up and down, 119, 157, all the way up here. So that varies the depth quite effectively. The input is just you've got one way it goes through 100k, and the other way it lowers the signal by half by having 100k to ground. I don't know how I did that. It's only half the sensitivity, but I suppose it's better than nothing. So the circuit is just like many other Watkins, Scouts, Dominators. All the components are very similar, never exactly the same. There's always some small variation on the amps. And somewhere there's some little component being changed. But anyway, it's very similar. And it's very quiet now, this amp, so everything's working, so we can do a sound check next and see what it sounds like. Got it plugged into the normal channel, tone on max, can't see the controls, but the tone's on max, and the volumes are not quite up full. I've got the Strat plugged in just straight into the back. Strat's on treble, so let's just do something. So that's in that channel. Now, if I plug it into the other socket, it's got the two gain, two ECC 83 halves joined together in the other socket, and it's a bit. Let's put it onto a bassier sound. On the bass, and put it back onto the one of the in-between sound. Now if I put it into the tremolo input and turn the volume up, got tone on max, turn the volume up, and I plugged it into the tremolo channel. Got the tremolo on slow, that's as slow as it goes, and the fastest speed is slowest speed. it's got plenty of power, just the strap plugged straight in. Turn the speed up. Nice punchy sound, very nice indeed. And turn the tremolo off, it's still in the tremolo channel. Very punchy sound, very nice. Really punches through. That's a great sound, that is. So it's pretty quiet actually, and it's just a really nice sound. These whems are just brilliant. Really punches through. Well, it's a very punchy sound indeed. So that's it.